We already learned in 11th class about the left hand limit, a right hand limit and the limit of a function. Now let us consider a function here. F of x is equal to s plus 2 when x less than 1, 2 when x equal to 1, negative x plus 2 when x is greater than 1. We are going to find a left hand limit at x equal to 1. So when x is approaching 1, taking value slightly less than 1, what is happening to the y value? Y value is approaching 3. X is approaching 1 from left hand side, then y is approaching 3. So this tending value is what is called the left hand limit here. So that is left hand limit is equal to limit of fx as x tends to 1 minus that is equal to 3. LHL is 3. Now what about the right hand limit? This time x is taking value slightly greater than 1. X is approaching 1 but taking value slightly greater than 1. See, x is approaching 1, then y is approaching 1. X is approaching 1, fx is approaching 1. So you can see the tending value here, it is 1 only for fx. So that is the right hand limit. So we can speak of right hand limit is equal to limit of fx as x tends to 1 plus that is 1 only. Now what about the value of the function, that is value of fx at x equal to 1? You see here, when x is 1, y is 2, that is fx is 2. So f1 is equal to 2 here. And we can see that LHL, RHL and value all are different. Let us compare all the values. See, LHL is coming, RHL is taking and the functional value. But LHL is becoming 3, RHL is becoming 1 and value of the function is 2 only. So they are all different. Now let us consider another example. Say fx is equal to s plus 2 when x less than 1, 2 when x equal to 1, negative x plus 4 when x greater than 1. Again we are going to take the LHL and RHL at x equal to 1. So let us consider left hand limit. Again x is approaching 1, taking value slightly less than 1. So x is approaching 1, then fx is approaching 3. X is approaching 1, fx is approaching 3. So we can have the LHL, that is left hand limit is equal to limit of fx as x tends to 1 minus that is equal to 3 here. Now what about RHL at x equal to 1? So we are taking value slightly greater than 1 but approaching 1. So see, x is approaching 1 and the fx is approaching 3. X is approaching 1, fx is approaching 3. So the tending value of fx is 3. So we can speak of right hand limit here, that is RHL is equal to limit of fx as x tends to 1 plus is equal to 3. Now what about the value of the function at x equal to 1? So when x is equal to 1, what will be fx value? Look at it here, when x is 1, fx is 2, x is 1, fx is 2. That is f of 1 is equal to 2. Here we can see LHL is 3, RHL is 3 and f of 1 is 2. Let us see all the cases together. LHL is there, RHL is here and value of the function is there. And what is happening? You see that LHL and RHL are becoming the same. They are coincident. But f of 1 is 2 only. LHL is equal to RHL, each is 3 only, but the f of 1 is 2. So this is the second case. LHL is equal to RHL but not equal to the value of the function. Okay, let us consider another example here. Again we are going to find the LHL and RHL. So x is approaching 1, taking value slightly less than 1. X is approaching 1, fx is becoming 3. X is approaching 1, fx is becoming 3. So the tending value of fx is 3 here. So we can speak of left hand limit, that is LHL is equal to limit x tends to 1 minus fx is 3. Now what about the right hand limit? So right hand limit at x equal to 1. we are approaching, x is approaching 1 and fx is approaching 3. You can see x is approaching 1, fx is approaching 3. Therefore, we can speak of a right hand limit here, that is RHL is equal to limit of fx as x tends to 1 plus, that is equal to 3. Now, what about f1? When x is 1, you can see f of 1 is 3 only. X is 1, f of 1 is 3. That is f1 is equal to 3. Here, all the values are equal. Let us see all the cases together. Left hand limit is there, right hand limit is there, and the functional value is also there. We can see that all the values are becoming coincident. They are all becoming coincident. So that is fx left hand limit is equal to 3, right hand limit is equal to 3, and f1 is also is equal to 3. All the values are coincident. That is the third case. Now let us compare all the results together. In case 1, what was the LHL, can you recollect? LHL is equal to 3 and RHL is equal to 1 and f of 1 is equal to 2. And we see that all are different. And we see that all are different. And in case 2, what was LHL? LHL is equal to 3 is equal to RHL, but f of 1 is equal to 2. That is, in case 2, LHL is equal to RHL, but not equal to f of 1. In case 2, LHL is equal to RHL, but not equal to f of 1. And in case 3, what was LHL? LHL is equal to RHL is equal to f of 1. LHL is equal to RHL is equal to f of 1 is equal to 3 here. That is, limit of fx as x tends to 1 minus is equal to limit of fx as x tends to 1 plus is equal to f of 1. And when this LHL is equal to RHL, we can speak of limit. That is, limit exits here. Exits means exits as a finite number. And what is that limit? Limit is the common value of that LHL and RHL. And that is 3 here. That is, limit of fx as x tends to 1 is equal to 3. That is, limit of fx as x tends to 1 is equal to f of 1. Then, in such a case, we can say that the given function y is equal to fx is continuous at that point x equal to 1. That is, the given function y is equal to fx is continuous at x equal to 1 because the value of the function at x equal to 1 equals the limit of the function at that point x equal to 1. If the function is not continuous at x equal to 1, we can say that the function is discontinuous at that point. And we can say that x equal to 1 is a point of discontinuity. So in formal way we can say, suppose f is a real function on a subset of real numbers and let C be a point in its domain of f, then f is continuous at C if limit of fx as x tends to C is equal to f of C. That is, the value of the function at x equal to C equals the limit of the function at x equal to C. Then one can say that the function is continuous at that point x equal to C. If the function is not continuous at C, then we can say the function is discontinuous at that point C, and C is called a point of discontinuity of f.